Hey everybody, this is Mr. Ainsworth, and we're going to get into compounding money. In other words, how does money grow over time given certain interest rates and a starting principle? All right, to do this, there we got to go back to the geometric sequences here and the recursive formula, because believe it or not, money grows according to a geometric sequence or what's called the exponential growth model. Okay, so let's do a little review here. We already know that for geometric sequences, the recursive formula is p sub n, all right, is equal to r times p sub n minus 1, where this right here, p sub n minus 1, represents your previous, all right, population or previous term. And in this case, what we're going to do is we're going to call our populations, they're going to be actually in respect to money here. They're going to represent the money that is growing over time, or the amount after one transition over time. Okay, and we have to understand that the p sub 0, which we initially call the seed, all right, or the initial amount. So let's highlight that. All right, this guy is going to be representing the initial investment or the initial amount uh, in the situation here. We multiply that times r to get p1, then multiply by r again, the common ratio, to get p sub 2, and then multiply by r again, get p sub 3, and this happens again and again, and you multiply by p sub 4 by r to get all the way to your nth population or your amount after n transitions. All right, so p sub 1 represents the amount after one transition. P sub 2 stands for the amount after two transitions or two time periods. All right, and so what we want to do is develop that growth model again and relate it to money so we can study how money grows given a certain interest rate and a starting investment, or what we call a starting principle. Okay, so we understand that p sub 1 is nothing more than p sub 0 times r. What we want to do is rewrite each term here in respect to the initial amount, because we want to be based upon this guy right here, p sub 0, which we called the seed earlier in the lessons. Looking at p sub 2, we can go all the way back in time to p sub 0 and multiply by r and then r again. So we multiply r twice. So we take p sub 0, the initial amount, times r, and if you simplify this, r times r is r squared, and we get p sub 0 times r squared. And then p sub 3 can be found by going all the way back to the beginning, p sub 0, multiplied by r 3 times in a row, times r, times r, times r, to get to p sub 3. Well, that means that p sub 0 times r times r times r is nothing more than p sub 0 times r cubed. Now, if you look closely here, the subscripts right here matches your exponent. All right, because of that, we have the exponential growth model, p sub n is always equal to p sub 0 times r to the nth power, where n equals the number of transitions, okay, or time periods that go on. And that time period varies depending on the growth model, depending on what we're doing here. All right, so in case of money, and when we're talking about how we compound money here, p sub n is not going to refer to people or things or sheep or whatever you're talking about. It's going to be representing the future amount of money, okay, future amount, okay, after n transitions, after, okay, n, okay, transitions or time periods. All right, p sub 0 is your starting amount in dollars. You can say starting amount, or you can say initial amount, whatever you want. R is going to be your growth rate. How much is it growing over the time? So I call that the growth rate, otherwise known as the common ratio, right? It's the multiplication factor that you're using to multiply each population by to get to the next population. It's your multiplication factor, basically. And n is going to be standing to the time period, okay? N is the number of time periods. We call those the transitions, but in money, it kind of makes sense to call them time periods because guess what? That's what they actually are. Okay, so I'm going to put time periods / transitions because that's the terminology that you guys are used to seeing. All right, so let's go for it. Let's apply the exponential growth model to uh, money here, and we're going to study how money grows 4 different ways. We're going to do it by what we call compounding annually, and then we're going to do it by compounding quarterly, and then monthly, and then daily. And if you want to go further, you can study how it's compounded continuously as well. But right here in this lesson, we're going to do it using 4 different methods. So what we have is an initial investment of $4,000. That's going to be your initial amount, P sub 0. The annual interest rate is right here, 8%. So I'm going to write down 8% right here. And it's going to be compounded annually. So that is super important. That means one time a year. Annually means per year. One time per year. Okay, what we want to do is find the first three, the amounts for the first 3 years. We're going to call that P sub 1, P sub 2, P sub 3. We're going to write the explicit function, your exponential growth model, and then find the amount after 30 years in this case. Because in this case, we're talking about years. Now, the interest rate determines the growth rate. Okay, if it increases 8% every year, that means we have 100% of what we started with plus that 8%. Okay, which is obviously 108%. And then, of course, you want to change that to a decimal. You take 108 divided by 100 because percent means per 100, and you get 1.08. Or if you want, you could use a calculator, divided by 100, which shifts the decimal 2 places left, and you get 1.08. Okay, so there's your growth rate. So what we're going to do is we're going to start off with this initial investment of $4,000. We're going to watch it grow by multiplying by our growth rate by 1.8. So what we do is we start off with $4,000, and you should be working with me side by side with your own calculator and not just watching. Okay, you learn mostly by doing here. All right, and you multiply it by 1.8. Or excuse me, 1.08. There we go. And we get the amount after 1 year, which is $4,320. So $4,320. So what we do is we're going to start with P sub 0 here. You multiply it by 1.08. You keep multiplying by 1.08 to get to the next amount in the sequence here. All right, that's how you do it. And then you keep on doing that. So you got to multiply again by the growth rate, which is 1.08, which is 108%. So you multiply by 1.08. Notice that it didn't clear it. I just say times 1.08 right there. And we get the next amount, which is $4,665.60. So $4,665.60 right here. Okay, you just keep on going. What's cool about the TI-84 is that if you just hit the enter button next, it recalls what you just did right there and remembers it, and you can get as many values as you want just by hitting the enter button, which is kind of cool. All you have to do is round it to the nearest penny. All right, so this next one here is $5,038.85 because we got to round to the nearest hundredth because, well, there's 100 pennies in a dollar, and that's the smallest unit of money that we have. So we have $5,038.85 if we take this and multiply it by the growth rate, which is 1.08 each time. And again, you just keep on multiplying to get to the next term in the sequence in any geometric sequence. That's how these things are done. And also notice that this number here, P sub 3, this can be found by going back to the original amount and multiplying by 1.8 once, twice, 3 times, which means that P sub 3 can be found by this way, by taking 4,000 times your growth rate to the third power. That's what happens when you multiply it 3 times in a row by 1.08. And if you do that, let's verify what I'm saying here, is you take 4,000, you multiply it by 1.08, all right, raise it to the third power, and you'll notice that you get the same thing. Okay, notice it's the same numbers right there. Which means, my friends, that the growth model, this is your exponential growth model here, is P sub n is equal to the original amount, P sub 0, times the growth rate, 1.08, to the nth power, where in this case n represents number of years. Okay, because we're doing it annually one time a year. Number of years. Okay, so let's highlight this. Okay, there's your exponential growth model. Remember, in general, it's always p sub n is equal to p sub 0 times r to the nth power. All right, notice that form here, and that's what I started with in the very beginning. It's right here. Okay? Notice that they are in the same form. There's supposed to be an arrow here. Okay, all right. So let's answer the second question here. How much money will there be after 30 years? Remember, this is years, right? So it's 4,000 times 1.08, all right, to the 30th power. What would that be? Well, let's figure it out. So 4,000 times the quantity 1.08 raised to the 30th power, because we're doing it over 30 years. And you have to round this a little bit here. It's $40,250. All right, and what was it? 63 cents, I think. Let's double check that. Yep. You have to round it. Look at the 7. You got to round the 2 up one, right? Because you got to round 2 nearest hundredths, because there's 100 pennies per dollar. All right, the smallest unit of measurement, the smallest unit of money is pennies, at least in our system. And then how much will there be after 45 years? Well, that's a piece of 45. So, so a piece of 45, so it's 4,000 times 1.08 to the 45th power. You whip that out. So 4,000 times 1.08 raised to the 45th power. And you get $127,681.80. Okay. So $127,681.80. There you go. And so if you left $4,000 untouched in the bank at that interest rate, 8%, and if it's compounded annually, you will have over $127,000 after 45 years. Okay? Okay, now you guys got to get involved. So what I want you to do is kind of pause and play here. I want you to pause the video now, give this a shot, and press play when you are done. Okay? Pause and play. Okay, I'm going to assume you're done now. So the annual interest rate is 6% in this case. So the growth rate is 100% plus the 6%, which is obviously 106%, which is 1.06 as a decimal. And what we want to do is invest $2,500 now and see what happens over time. So we're going to start off with $2,500. We're going to multiply it by 1.06 and see what happens and go with the flow. So $2,500 times 1.06, $2,650. All right, so we should have $2,650 in the bank, a gain of $150. All right, that's your interest. That's what the bank pays you after 1 year. So $2,650. You multiply that by 1.06 again. So times 1.06. And you get 2809. So $2,800 and it's $2,809. Okay, you multiply that by the growth rate again. So and just hit the enter button here and it does it for you, because it remembers what you do after 2 iterations. So it's $2,977 and 54 cents. Okay, we're rocking and rolling here. Okay, these are all money values. So our explicit function right here, big time, is $2,500 times your growth rate to the nth power, where n stands for years, n equals number of years again. All right, so how much will we have after 30 years? Well, 1.06 to the 30th power times 2,500. I don't know, let's figure that out. So 2,500 times 1.06 raised to the 30th power. Here we go. That's wrong because I entered it incorrectly. So let me start over here. So if you go too fast, you make silly mistakes like that. My answer didn't make sense, so I knew I made a mistake. This is more likely right here. So $14,358, okay, and 73 cents after 30 years. Okay, how much will it be there after 45 years? Well, that's a piece of 45. So 2,500 times 1.06 to the 45th power. So 2,500 times 1.06 raised to the 45th power. And we get a little over 34,000, right? So $34,411.53. Okay, after 45 years. There we go. Okay. All right. Once again, pause and play. Pause the video and then play when you're done. Okay, I'm going to assume you did this here. So we're going to invest 10,000 at 12% compounded annually. Okay, that's one time per year. So let's take 10,000 at 12%. That means we have 112%, or the growth rate is 1.12. So we're going to multiply this by 1.12 and see what happens over time. So let's clear it out. Enter in 10,000. Make sure there's 4 zeros there. Times 1.12, and we'll get 11,200. So after 1 year, this is the first year, we've gained $1,200. Remember, this is money now. Then we multiply that by the growth rate again. So times 1.12, and we get 12,544. So now I made $2,544 in 2 years, because remember, this is the second year, right? We're going to do that one more time. And we just hit the enter button, and we get $14,049. Okay, and how many cents? 28 cents. So 28 cents. So in general, you take $10,000 times your growth rate, raise it to the nth power. So after 30 years, we should be able to take 10,000 times 1.12 raised to the 30th power. So 10,000, make sure there's 4 zeros there, times 1.12, raise it to the 30th power, and we get a lot of money here. We get 299,000. $599, okay, and 22 cents. Okay, this is after 30 years. After 45 years, we're going to have even more than that, right? Because we got to take 10,000 times 1.12 to the 45th power. So let's do that. Let's take 10,000 times 1.12, raise it to the 45th power. Yeah, 45th power here. So here we go. Oh, I didn't enter it correctly here. So let me see. There we go. Enter in 45, and we get 100. And oh, what happened here? What am I doing here? Oh, that's right. So we get 1,639,000. 1,639,000. All right, 876, I think it was. Let me see. $876 and 4 cents. Okay, there we go. So we get a lot of money in 45 years. If you let $10,000 ride for that long, 45 years, compounded annually at 12%. Not very realistic right nowadays with today's economy, but hey, that's the way it goes. Okay. Now, when you do it quarterly, that means quarterly is 4 times per year. There are 4 quarters per year, right? So 4 times per year. That means every 3 months, 12 divided by 4 is usually 3. So every 3 months, the bank puts in interest in your account. All right, and your money grows faster this way because they do it 4 times per year versus only 1 time per year. So this is better than what I just did. So if you take $4,000 at 8% and invest it, and where it's compounded quarterly, we're going to end up with more money over time. So here we go. The quarterly interest rate, you have to divide it by 4. So 8% divided by 4 is obviously 2%. So the growth rate is 100% plus that. This is called the periodic interest rate, so which is 102%. So you get 102% of your money every quarter or every 3 months. The bank pays you 2% interest every quarter. So let's calculate that. So let's start off with $4,000. Here we go. Let's clear it out. Start with 4,000. We're going to multiply it by 1.02 to get the amount after 3 months, or the amount after every quarter. So 4,080. So we multiply that by the growth rate, 1.08. So this represents your first quarter. P sub 2 represents your second quarter, the amount after second quarter, or after 6 months. And then P sub 3 represents the amount after 3 quarters or 9 months, because they're 3-month periods. So let's keep on doing this. Let's multiply it by the growth rate again. Let's see what happens. So times 1.08, and we get $4,406 and 40 cents. Okay, you got to round it to the nearest penny. So we didn't have to round right there. It's just 0.4. It's 0.40. It's the same thing. So, wait, did I type that in right? Let's see. No, I didn't. Let me start over again. That was wrong. So, sorry. I got to fix that. I got to put in the right number. This is... Oh, I got to fix this. I'm sorry. We got this right here is 1.02. Jeez, come on, Ainsworth. So 1.02. I can't believe I did that. It's been a long day. I apologize. I knew something was wrong. So let me fix this, so I don't have to redo the video here. So times 1.02, which is your quarterly rate. Okay. So what do we get? So we get 4,080. Multiply it by the growth rate, which is 100% plus 2%, or 102%, 1.02. There's your growth rate. So times 1.02 again. That's where I made my mistake earlier. And I get, this is better, $4,161 and 60 cents. Okay. Multiply that by the growth rate again. So just hit the enter button, and you get $4,244. All right, and 83 cents. So in general, you take your initial amount, which is right here, so 4,000, times your growth rate, which is 1.02 to the nth power, where n here equals the number of quarters, not years. This is very, very important right here. Because if you don't understand that n doesn't represent the years, it represents the number of quarters or 3-month periods, then you can't answer the next question. Check this out. How much money will be there in the account after 30 years? Well, since n stands for a number of quarters, or, because they're 3-month periods, we got to figure out how many quarters are there in 30 years. So the very first step on this one is you got to figure your n value. Now we know there's 4 quarters per year, so you got to take 30 times 4. All right, and that's obviously 120 quarters in 30 years. So we got to find P sub 120, not P sub 30. The most common mistake people make is they just go P sub 30 and they get the problem wrong. They have to understand the subscript. N stands for quarters here, not years. So you got to take 4,000 times 1.02 to the 120th power. See what you get. So 4,000 times 1.02 raised to the 120th power. And look what you get. Okay. Did I type that in right? No, I didn't. That's 110. Oh, man. I am... At least I'm fine. I'm checking. I'm finding my mistakes when I make them. I got to take it to the 120th power. I didn't hit the right key. Okay, 43,000. All right, $60.65. So $43,065. Okay, and $60. Excuse me, and 65 cents. Now in 45 years, let me see. 45. Each year has 4 quarters. 45 times 4 is 180, so there's 180 quarters there. So we got to find piece of 180. So that's found by taking 4,000 times our growth rate to the 180th power. So let's do that. So 4,000 times 1.02, raise it to the 180th power. And we don't get anything. Why is it? Oh, it's because I put 2 decimals in there. See? User error. Okay. Come on. You gotta love this. This is what's gonna happen to you, after a long day. So you just gotta go with the flow, check your work, obviously with me, and then make sure you do it right. So we have $141,283.33. Okay. So here we go. So $141,283.33. Okay, and that's how you compound it quarterly. When the bank adds interest every 3 months, not just once a year, 4 times per year, because again, they're 4 quarters per year, right? Right. Okay, what I want you to do is pause and play again. Try the next one. And press play when you're ready. All right, here we go. Let's check your work. We're going to invest 2,500 bucks at 6%. Now you got to take 6% divided by 4. Now, if you can't do that in your head, you do 6 divided by 4. That's 1.5. So this is 1.5%. So to get your growth rate, you got to add that to 100. So 100 plus 1.5 is obviously 101.5%. So R is equal to 1.015. Okay. Now, if you ever have trouble and you're not sure about how to change a percent to a decimal, just divide it by 100 and see what happens. Okay. You'll notice that all you have to do is shift the decimal 2 places to the left. All right, so let's multiply that by the growth rate, which is 1.015. Here we go. So let's clear the calculators. Enter in 2,500. I'm just too fast for my calculator. Okay, so times 1.015. And you get $2,537.50. Okay, let's multiply it by 1.015 again. Times 1.015, hit enter, and you get 25.75, 56 cents. Okay, and then you do it one more time. All right, and okay, let's see what happens. We got $2,600, $2,614.20. And then again, the explicit function, or your exponential growth model, would be 2,500 times 1.015. 1.015, there's your growth rate, to the nth power, where n represents number of quarters. Why? Because we're doing it quarterly, right? Quarterly. Okay, so we're going to take this, we're going to apply it here. Okay, so we're going to, in 30 years, you got to figure out n first. So 30 times 4 is 120 quarters. So P sub 120 would be 2,500 times 1.015 to the 120th power, which is 2,500 times 1.015 raised to the 120th power. So you get $14,923.31. In 45 years, that's, let me see, 45 times 4, 116, 180 quarters. That's a piece of 180. So that's 2,500 times 1.015 raised to the 180th power. So you take 2,500 times 1.015 raised to 180th power, and you get 36,000. All right, $460.92. Okay? All right. Now the third method is compounding monthly. All right? So that means every month, every 12 months, 12 times per year. 12 times per year. Why? Well, because guess what? There are 12 months per year, right? So we're going to invest 4,000 at 8% compounded monthly this time. So let's take 4,000 at 8% compounded annually. Compounded monthly. So 8%. They get the monthly interest rate. We got to divide that. Ooh, let me see. There's 12 months per year, so you got to divide that by 12. And you got to be careful in this one, because this one here, if you take, let's clear the calculator. If you take 8 divided by 12, you notice something happens here. We get a decimal here. And you do not want to round this and use a rounded number in your growth rate, because what will happen is if you project out in 25 years or 50 years in the future, your answers are going to be so far off from reality, it's not going to be funny. All right, so we do not round. So I'm going to put this big bold in red. Do not round. Okay, so don't write that as 0.67 or even worse yet, 0.6. Don't do it. Okay, don't round. What we're doing is just use it. So the growth rate, as I said earlier, is found by taking that and adding it to 100%. So you just write it in exact form. And then you change both of these to decimals. So R is equal to 100% is 1 plus 8%, which is 0.08, divided by 12. There's your growth rate in exact form, okay, not rounded. Do not round. So we got to multiply this times the quantity 1 plus 0.08 divided by 12. Now, when you use your calculator, use your parentheses. So enter in your initial investment. Notice that I use parentheses here, times 1 plus 0.08 divided by 12, and hit enter. And you'll notice that I get a little bit more, right? Because this is every 12 months. This is after 1 month, piece of 1 cents, the amount after 1 month, I gained $26.67. So I have 4,026 and 67 cents. I gained $26.67 interest after the first month. Now, after 2 months, let's see what happens. We got to multiply that again by the growth rate, which is 1 plus 0.08 divided by 12. Let's see what happens. So times quantity, okay? 1 plus 0.08 divided by 12. Oh, shoot. I pressed the wrong button. Okay, so let me start over. Okay, so I fixed it right here. You have to divide it by the right number here. So I get $4,053.51. $4,053.51. Multiply it by the growth rate again, which in exact form is 1.08 divided 1 plus 0.08 divided by 12. What's cool about the calculator is that you just have to hit the enter button and it recalls what you did if you did it twice in a row. So now I have $4,080.53. So already after 3 months, this is the third month. Remember, these are in months now, not years. I made $80.53, which doesn't sound like a lot, but remember, the bank's gonna do this 12 times per year. So you take the initial investment, multiply it by your growth rate, raise it to the nth power, where n now stands for the number of months now. Okay, so now let's use that model and answer the following questions. In 25 years, how many months do we have? Okay, well, you got to figure that out first. We know there's 12 months per year, so let's multiply. So 25 times 12, and that's 300. So there's 300 months. So I got to find P sub 300. So I'm going to take 4,000, multiply it by my growth rate, raise it to the 300th power, and see what I get. So let's do that. So let's take 4,000 times our growth rate, raise it to the 300 power, check it to make sure you inputted it right, and then press go, and I get $29,360.70. So $29,360.70. In 50 years, we got to figure out how many months there are. So 50 times 12, that should be 600, but let me check. So 50 times 12, 600. There's 600 months. So you got to find P sub 600. So we're going to take your initial amount times your growth rate, raise it to the 600 power, and see what we get. So here we go. So I'm going to recall the, no, I'm not going to do that. Oh, shoot, I didn't mean to do that either. That's all right, I'm going to start over. So 4,000 times 1 plus 0.08 divided by 12, raise it to the 600 power. See, I made a mistake there. So I'm going to fix it. There we go. $215,512.73. So $215,512.73. There we go. All right, now time for you to try it. So pause the video, give it a shot, okay, how to compound monthly. When you're ready, press play. Okay, so here we go. We're going to invest $2,500 at 6% annually, but we're going to compound it monthly. So 6% divided by 12, that's, let me see, 6 divided by 12, that's 1/2 or 0.5, right? So 6 divided by 12. For some reason it's not. Oh, my computer's slowing down. So is 0.5. 1/2 is equal to 0.5. So this is 0.5%. So I've got to take 100% plus 0.5%, which is 100.5%, which is 1.005. Here's my growth rate. So I got to multiply it by 1.005. So enter in 2,500 times 1.005, and I get $2,512.50. So I just made $12.50 in 1 month. So this is the first month. What happens in the second month? So let's figure out. Let's multiply it by your growth rate, 1.005. So times 1.005, and you get $2,525.06. So $2,525.06. You keep going, you multiply it by the growth rate, and let's see what we get. So we get $2,537.69. So $2,537.69, which means our exponential growth model is 2,500 times the growth rate, 1.005 to the nth power, where n stands for the number of months in this case, because we're doing it monthly, right? So you take this growth model and you apply it down here, and you solve these problems, okay? So how much money will there be in 25 years? Well, you got to figure out how many months go by. So there's 12 months per year, right? So 25 times 12, well, that should be 300 months. So you take P sub 300 and you figure that out. So take 2,500 multiplied by your growth rate, and you got to raise that to the 300 power, because they're going to compound it 300 times during that period of time. So let's figure out what that is. So you're going to take 2,500 times your growth rate, raise it to the 300 power, okay, and you get 11,000. No, that's not right because I didn't enter in the right number there. So let me start over. I entered in 25,000, not 2,500. So you got to be careful. It's usually use your error when it comes to the calculator. Sometimes it's a setup issue if you don't know how to approach the problem, but as I just illustrated there, if you don't put in the right numbers, you're not going to get the right output. So we get 11,162. This is more like it. $42. Okay, now in 50 years, let me see, 50 times 12, that should be 600 months. You can verify that, so let's do it. So 50 times 12 should be 600. So a piece of 600 is 2,500, not 25,000. Come on, Ainsworth. I'm getting close to my limits on this video here. So raise it to the 600 power, and let's see what happens. You know, running these videos for you guys is not only time consuming, but it also is mentally exhausting because I'm going and going and going. Oh, I didn't use parentheses correctly. So that's the problem. So you got to use parentheses correctly. See, like already I'm making simple little errors, which is causing a little problem here. All right, but at least I'm smart enough to fix it. So here we go. So I've got $49,839.89. So $49,839.89. Okay, there you go. All right, so the only thing we have to do is compound daily, and then we're set. Well, we can compound continuously, but that's not in this lesson. That's in a future lesson. So here we go. Let's invest 4,000 at 8% annual interest rate. All right, but this time we're going to compound it daily. All right, that's the key. And that means we're going to compound it 360 times per year. That means that the bank's going to put in interest daily. Your money's going to grow after the first day, not after the first month, not after the first quarter. But every day is going to grow. So this should grow faster. This is a better situation. Okay, so interest rate is 8% annually. Now we got to get the daily interest rate. Daily interest rate. So you got to divide that by 365, right? Now, if you do that, if you take 8 divided by 365, you're going to get a decimal. And like I said earlier, we do not round, because if you round this off and use a rounded number, your answers are not going to be even close. Okay, so remember that. So you take that and add it to 100%, because this is an increase, not a decrease. And so R is equal to 1 plus 0.08 divided by 365 now. So we start off with $4,000 initial investment. We multiply it by our growth rate, which is 1 plus 0.08 divided by 365. So let's do that. Enter in your initial investment. Use parentheses now. You have to do that. Every calculator has parentheses. So times 1 plus 0.08 divided by 365. That gives us our daily interest rate there. Okay. And notice that it's not a whole lot more. Why? Because this is after only one day. All right. So we only have $4,000.88. All right. I didn't expect very much because we're doing it daily now. We get 88 cents interest. So after the first day, on day number 1, we have $4,000.88. Now after 2 days, after the second day, what do we have? Well, we got to multiply it again, right? By the growth rate, which is 1 plus 0.08 divided by 365. So we just go times quantity, use parentheses, 1 plus 0.08 divided by 365. Make sure you put it in correctly, and you got $4,001.75. So check this out. We made $1.75 after 2 days. Woohoo, right? And it doesn't sound like much, but guess what? You're going to do this 363 more times. because there's 365 days a year, right? So they compound it every day. They put money in your account, which is called interest, in your account every day. All right, so let's do this again and multiply it by a growth rate and see what happens after 3 days and see what we get. Just hit the enter button. It comes free. So we have $4,002.63. So we made $2.63 after 3 days. Remember, this stands for the third day, right? Okay, so overall, what do we have? We take the initial investment, we multiply it by our growth rate, and we raise it to the nth power, where n this time, n equals the number of days that have passed. So you got to keep that in mind. There's your exponential growth model. And then after you do that, you can solve all kinds of problems, right? So after 20 years, well, let me see, 20 years. In 20 years, how many days are there? So n equals 20 times 365. So 20 times 365, that equals 7,300 days. So the bank is going to compound or add interest in your account 7,300 times over a 20-year period. So you have to figure out piece of 7,300. So you take your initial investment. That crazy sound in the background, by the way, is my piggy, who's really hungry right now. She's being fed. All right, and you raise it to the 7,300 power. And what do you get? Well, let's see here. We got to figure that out, right? So 4,000, all right, times the quantity 1 plus 0.08 divided by 365. Oh, I didn't raise it to the power, so I got to redo that. So 4,000. Once again, this is it's usually user error, right? When it comes to calculator work, you got to raise it to the right power. And so it's going to compound or be multiplied by the growth factor 7,300 times over a 20-year period, and you get $19,808.66. So $19,808.66. Now over 40 years, well, let me see, 40 times 365. What's that? So 40 times 365. 14,600. There's 14,600 days in a 40-year period. So we got to find piece of 14,600. So we're going to take our initial investment, multiply it by a growth factor. Raise it to the 14,600 power. Let's see what we get. So let's multiply it by our growth factor. I just made a mistake there, but I caught it. 0.08 divided by 365. Raise it to 14,600. Wow. Pretty cool that you can do that on a calculator. And you get $98,095 and 72 cents. Okay? So what you need to do is practice, okay? So go ahead and pause the video and do your last example there. All right. Okay, here we go. Let's invest $2,500. So here we had 6%. We're going to compound it daily. The daily interest rate is 6% divided by 365, but like I said, don't divide and round right there. Just leave it as is. This is 100%. The growth rate is 100% plus that. So R is equal to 1 plus 0.06 divided by 365. So let's go ahead and go for it. We're going to multiply by our growth rate. Okay, let's clear the calculator. Enter in 2,500 times quantity 1 plus 0.06 divided by 365. And we get a little bit more than we started with, $2,500.41. Okay, we just made 41 cents after 1 day. And then you multiply it by the growth rate again. So times quantity 1 plus 0.06 divided by 365. And we got 82 cents now. So we just earned 82 cents after 2 days. Remember, this is the second day, right? These are just daily here. So one more time, multiply by the growth rate. Just hit the enter button on the T84, and you get $2,501.23. Okay, 23 cents, I guess. Yep. So we made $1.23 in 3 days. Woohoo! All right, so in general, we take $2,500 multiplied by a growth rate. Raise it to the nth power, where n stands for the number of days. All right, now let's use it. In 20 years, we have 20 times 365. So 20 times 365, that's 7,300. So we have to find piece of 7,300. So it's 2,500 times the growth rate to the 7,300 power. Okay, I didn't type that in right. That's wrong. So going too fast. So 1 plus, I didn't get the plus button, 0.06 divided by 365. Raise it to the 7,300 power. There we go, that's better. $8,299. All right, and 47 cents. In 40 years, let me see, so n is equal to 40 times 365. 14,600 days. So a piece of 14,600 equals 2,500 times your growth rate raised to the 14,600 power. There we go. And we get $27,552. All right, and 51 cents. Okay, and the only thing you have to do is get good. So what you're going to do now is you're going to do a full review over all 4 methods. Okay, as you can tell here, it's the same amount you're investing, 8,000 in all 4 cases. Your annual interest rate is 12% in all 4 cases here. And what I want you guys to do is calculate, each amount and figure out what you're going to get in 45 years, whether you compound it annually or quarterly, because you got to read the directions here, or monthly or daily, and figure out which method is the best. I mean, if you had $8,000 and the annual interest rate is 12% in all 4 cases, which method gives you the most amount of money in 45 years? So do this, work on this, and I'll see you in my next lesson. This is Mr. Ainsworth. I'm out of here. Bye-bye.